For 14.2, on your own, we're going to be working with dot plots. We're going to be making dot plots and looking at the information we can learn from the dot plot. So if you know how to do this, you're welcome to go ahead. If you need to keep watching the video for help, then be sure to do that. So number 3 says that the dot plot shows the thickness of sheets of cardstock, which is a type of paper. So every single one of these dots is a piece of paper that they measured. So go anywhere from 7 millimeters to 8 millimeters and in between there. So the least thick measured is going to be over here. So our measurements are here, our papers are the dots. So we want to look and see the smallest measured paper. And then on the other end of the scale, we have the greatest measured paper. What is the most common thickness measured? So we look at our dots and we see which dots go the highest will tell us which measurement was the most common. So measurements, the numbers for measurements are down here. Which measurement had the most papers goes up the highest here. So it doesn't ask how many papers. So I can see this one is the highest, 1, 2, 3, 4, 5, 6. But what is the measurement of those, the most common here? So you have to understand the difference between the measurements and the papers. Let's go ahead and make sure you've answered those 3. Then we'll go on to number 4. So number 4 tells us that a group of people is asked to count the number of coins in their pockets or wallets. The number of coins each person has is shown. So each of these is a person that counted their coins. So every time we have a number, that's a person. The number is how many coins they have. So here they can see it goes anywhere from 0 up to 10. So we're going to complete the dot plot. So we're going to put a dot above each one. So I'm going to start and put a dot for the 7. Now remember, we want to, I'm going to make that a little thicker. We want to even these out, right? I shouldn't have one here, then start the other one here. Every first one should be in a row. Okay, then we have 10 and 2, 0. So make sure you're doing these. 6. So just every time there's a number, we place a dot. 8, 5, 3, 4, another 0. So we're going to add on to that one. 9, 1. So you can see, right, I did my best to kind of keep them in a row here, not all ski-wampus from each other. So they, okay, so I just did 9, 1, 8. So if you need to, like, mark it off and be like, yep, I did that one. There's my dot. Now I'm on 7. So my next one is 10. So we don't skip one or miss one or do one twice. And then 0 again. 5 and 7. So your dot plot should look like this. A dot for each person and their coins. So the most common number, right? So here's the number of coins. These are the people. So the most common number, we look for the highest. And I actually see 2 that have the same amount. So there's 2 that are going to be the most common. So unless I happen to miss one, but 0, 0, 0, 7, 7, 7. So I think sometimes we can have 2 things that are the same. How many observations are shown or how many people were asked? Every dot is a person that was asked. We want to count up the dots to see how many people they asked about their coins. Okay, let's see, D, letter D. What percentage of people had more than 5? So you have to, more than 5, not 5, more than 5. So we're going to look at these here. So we're looking at these people here. So we need to set up our problem. So more than 5 is 1, 2, 3, 4, 5, 6, 7, 8, 9 people had more than 5 out of a total of 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 that number 18 should match your answer to C. So it's the total people. So we had 9 out of 18 people. We're looking for the percent. We know percents are out of 100. So there's lots of ways we can do this. Is there a way to get from 18 to 100? Not off the top of my head. I can do 9 times 100 and divide it by 18. But I also noticed there's a way to get from 18 to 9. And if you notice that, we're going to do the same thing here. If you're not seeing that, then do 9 times 100, divide by 18 to find our percent. Okay, and then E asks what percentage of people had less than 7. So I'm going to switch colors here. Less than 7. So 7's not included in that. So we're looking at these people. My total should still be out of 18. There's still 18 people that were asked. We're looking for the percent. It's still out of 100. So less than 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we can see, is there a way to get from 18 to 100? I don't know that off the top of my head. So I'm going to do 10 times 100, which is, right, 10 times 1 is 10 with 2 more zeros. So that's 1,000. 10, 100 times is 1,000. And I'm going to divide by 18. I need something above the 1, the 1, the 1, the 1 here. So go ahead and try that out. Let me know if you need help doing your division. Okay, number 5 says the basketball team tracks the number of 3-point shots it makes per game during a season of games as shown here. So they made, right, so 3-point shots per game. So in one game they made 1, so every basketball is a game. That's what I was trying to figure out. A basketball represents a game, and this game they made 1, and this game they made 1. They have this many games where they made 2, this many games where they made 3, and so on. So how many games did the team score at least 3? So 3 is the lowest or higher. So we're going to count all the basketballs, right? These are the games. We're looking at the games. How many games did they score at least 3? So we're looking at this and over. So, and a basketball's a game. We're counting the basketballs. B, and how many games did the team score exactly 9 points? Oh, score exactly 9 points from 3-point shots. Guys, it's Friday afternoon and my brain is not mathing here. Okay, how many games did they score exactly 9 points from 3-point shots? All right, I'm back. You didn't know I left, but I am back after looking at the book and talking to another math teacher. I know what this question is asking. Whew, okay, so point for me, like I persevered. Okay, how many games did they score exactly 9 points? So, right, so every game, this is how many 3-point shots they made. So in this game, they made 1, so that was 3 points. So it's not that game. So it's not these, right? So here they scored 2 times, or they scored 2 3-pointers, 3, 6. That's not 9, so it's not these ones. Here they scored 3 3-pointers, 3, 6, 9. So this one, right, is actually 9 points. So each of these games is how many times they scored 9 points. Exactly. From 3-pointers. Whoo! That was harder than it needed to be. Okay. What is the most 3-point shots made in a game? So right here's their 3-point shots. Which one is the most? So it's not asking which one happened the most. It's asking which one had the highest points. And then what percent of the games did the team score at least 3 3-point shots? So at least 3, we've already answered that. At least 3 was 4, 5, 6, 7, 8, 9, 10, 11 out of the total games, 12, 13, 14, 15, 16. And we're looking for the percent out of 100. So I don't know a nice easy way to get from 16 to 100. So we're going to do 11 times 100 divided by a 16. I can tell you it's going to have 2 digits, a decimal, and 2 decimal places to finish that problem. So we're dividing by 16, right? 11 times 1 is 11 with 2 zeros. Whoops, I don't have my things lined up. Let me try that again. So 1, 1, 0, 0. So you're gonna have something with the 1. Can't go in here, can't go in here. How many times can it go into 110? How many times can it go into that? 2 decimal places. Whew, okay. Yay me. Okay, and number 6 tells us that a weight of gemstones, a set of gemstones, weights are listed. So we go anywhere from, it looks like our lowest is 0.1 up to 0.7 tenths, okay? So we're going to make our dot plot here. So here are the weights. And then, so these numbers we're listing are the weights. Every time we make a dot, that's representing a gem. So a gem is a dot. The weights are the numbers. You have to always be able to tell what are the dots, what are they being measured in. So we're starting at 0.1, 0.2, 0.3, 0.4. I'm going to let you keep going. 5, 6, 7. And I'm going to start and I'm going to put a dot above. There's 1. That's 2 tenths. And then maybe, right, I'm going to like check off that I did it. And then 5 tenths. I'll come over to 5 tenths and put 1. And then 1 tenth. You're going to go through each of those weights to put a dot. Let's go ahead and do that. And then we have 3 questions to answer. So the first one says, how many observations are shown? So that's how many gems are there, which are the dots. How many dots do you have on your dot plot? What was the most common size? So I'm looking for the one that goes up the highest, and I tell how much they weighed. And then which weight is the least common? So I'm looking for the lowest one. And remember, there could be more than one. Actually, there's not on this one, so I'll give you a little hint. So just 1 on each of these. So which one is the least common weight? So we're answering the numbers at the bottom, the weight based on how many dots they have above them. Let's go ahead and finish up 3 through 6 and get those checked off. Let me know if you need any more help.